Hey guys, this video is about calculating function inverses, so actually finding them given a function. If you didn't, please check out the first video. And the first video was about just understanding what functions actually are, how to recognize them, whether it's graphically, whether it's its meaning, yeah, so definitely check that out. Okay. All right, so we're going to go ahead and calculate functions. So given some function f of s, f of x, we want to calculate its inverse. And this is the way we write it. And I mentioned this before, but that's what this is. Remember, that's not an exponent. This is just indicating that this here is an inverse of this function here. So in other words, this is what we're saying. This is the definition. It's just saying if I put something into the inverse function into the actual function, it'll come out the exact input. So input equals, well, input. Well, anyway. Okay. So let's go ahead and start off, and we're going to start out with linear functions because they're the really the easiest and the fundamental building block to what we're doing. Okay. So I have two functions here, and they are inverses. I'll tell you that right off the bat. Now, it says show that they are inverses. Now, to show that they are inverses, there's a couple of things you could do. One of them is just loosely show it. Like, for example, if I said, let's put in some value of 3 into here, and then I take that output and I put that into the g function, I will get out 3. Okay, so we could show that pretty easily. Let's just try that. Okay, so f of 3. Okay, so what am I going to have? 6 minus 1, that's 5, right? So now if I take this into here, g of 5 had better get me out, what, a 3, right? So let's plug that in. Let's plug in that 5. So if we plug in the 5 plus 1 divided by 2, of course, 6 over 2 is 3, and that's a check. Okay, so that is just a very loose way of going, oh, hey, look, that's interesting. But what we really want to do is prove it. And to prove it, we can't just do it with a single number. We have to show that it would work for every single input, in which case we just do this. We are literally going to take the whole thing, this whole function, and we are going to plug it into here. Okay, and then that should undo whatever this does. So it should, once I plug in the function into here, it should simplify down to an x. So let's go ahead and do that. So notice what I did. Plugging in this, it just means I'm plugging this in, right? And where do I plug it into? It's input. Okay, so as I do that, now I'm just going to do some algebra, right? So if we look up here, right, the negative ones cancel. And then, of course, the 2's cancel, and we got exactly what we wanted to prove. So this is what we wanted to prove. And the thing is, it would work the same way, and please do so yourself, if I did this. So if I plugged in the g into the f, it'll give us the same thing. That's the whole characteristic of an inverse. Okay, so now that we've seen two and we've proved them, how do you actually get from one to the other? Okay. So if you follow these steps and you just do the same thing every time, and some teachers will give you a different way to look at it, but if you try this, you'll never fail. Okay. First thing, I usually don't write it as the fx. I usually write it as the y equals. Now, this indicates, again, we have a function, right? Whenever we have the x and y, that would be our function. So what I'm going to do is the first thing, step one, is I'm just going to swap variables. So I'm going to exchange variables. Okay. Now, the reason I do this first is so that I don't forget. And the whole thing I want to do right now is because I'm writing another function, I want to get y alone. That's my whole objective now at this point. Okay, get y alone. So to get y alone, of course, I'm going to add 1 to both sides, divide by 2, and I get to here. Once y is alone, we now have our inverse function. Pretty simple. Okay. So these two are inverses of each other. So if this is f of x, that would be f prime, or f inverse of f. Blah. Okay. All right. So pause this right now and try to find the inverse of this function. So please pause and give this a try. Okay. Hopefully you're back. Okay. So my first step is I'm not actually going to write it with f of x. I'll just write it with y, and then I'm going to swap my variables. Okay. Now at this point, my whole thing is I want to get y alone. So there's various ways that you could accomplish this. Like personally, my thing is I'll just get rid of the fraction first. I'll clear the fraction. Or you could subtract 12 and then clear the fraction. But whatever it is here, we'll just do it this way. Right, if I do this, right, I'm going to get 5x equals 2y plus 60. Now to get y alone, now I'm going to subtract 60 from both sides and divide by 2. Divided by 2, and that is my inverse function. Now, I could simplify this or show this slightly differently, right? Because that 2 belongs with both of these guys. So I could put that as 5 over 2x minus 30 equals y. So that's another way I could do it. So again, exactly like we did before, our whole objective once we exchange variables is just to get y alone, which will just take a little bit of algebra. So that is our inverse function. Okay. And again, these are inverses of each other. So if I plug this into here, I'm going to get out x. If I plug this into here, I'm going to get out x. Okay. Linear functions, the inverse of a linear function is always a linear function, except for horizontal lines. Those are not inverses, because the inverse of a vertical line would be a horizontal line would be a vertical line, which is of course not a function. Okay, now let's look at some basic nonlinear functions. Linear, pretty simple. Nonlinear, not that much harder, but just takes a little more thinking. Okay, so let's go ahead and try this. Now, I encourage you right now to pause and just do this on your own. See what you get. Okay, so hopefully you're back. Okay, just like before, I'm not going to do anything different. I'm going to write this as y instead of the f of x and exchange variables right now. Now remember, my whole objective is to get y alone. Okay, so to get y alone, I have to first get this thing alone. And to get this thing alone, I'm going to have to take the square root of both sides. So remember, when we take a square root across an equation, we have to consider the positive and negative roots. So we have to include that. Okay, so taking the square root of this squared, I'm here. At this point, I still want to get y alone, so I add 3 to both sides. So this would be our inverse. Now, be careful. This is definitely the inverse to our original function, but this by itself is not a function. Okay, because of this positive or negative here, this is actually going to end up being graphing out as like a sleeping parabola. So this is not a function, but it is an inverse. You can plug it in and see. We end up with 2 different answers here. So remember, a function is, because remember that positive or negative, remember a function says that for every 1 input, we get only 1 output. But here, if I put in 4 into this, notice I can get out either 5 or I can get out 1. So it's still an inverse. It's just not a function. The inverse is not a function. Okay, it's an inverse relation. Okay, let's try another one. Please pause and give this guy a shot. Okay, so I'm going to go ahead and go. So I already switched variables here, and I'm trying to get y alone. So the first thing I'm going to do is I'm going to multiply both sides by 7 to get rid of that. So clearing that, so I'll have 7x equals 5 plus. Now for this, I'm going to use this definition, right? Raised to the 1/3 power. Hopefully you're okay with that. So now the next thing, I'm going to go ahead and subtract 5 from both sides. So I'll have 7x minus 5 equals 2y, and this whole thing, right? Because this whole thing is underneath the radicand up here. Now I have to undo this 1/3. And of course, what I'm going to do is I'm going to cube both sides. But remember, if I cube this side, I'm not cubing each one of the terms. I'm cubing the whole thing. So be careful with that. Okay. So once we get to here, now is when we go ahead and take the divide both sides by 2. Now this is another way of showing it, and this is a nice way of showing it if you think about cubic functions, because this just tells you your scale factor here for the function. Okay, hopefully you got that. Okay, so I do have a function worksheet for you guys to get done. Please make sure to do this on a separate piece of paper. And if you have any questions, as always, give me a shout out. Bye.